This is part 4 of section 6.5. We have been solving quadratic equations. What we're going to move into now are some applications of quadratic equations. Now, one thing we know about quadratics is that we usually end up with two answers. Now, when we apply that to the real world, it is entirely possible that we get an answer that we need to throw away because it does not make sense in the real world. So, for example, if I ended up getting on this problem, don't even worry about all this yet, but if I end up getting that x equals negative 300, then that means this height would be negative 299, and we can't have a negative distance or a negative length. So that answer would have to be thrown away. So that's one of the things we have to be aware of. Okay, so let's look at this first problem. We are told if the area is equal to base times the height, find the base and the height if the area is 66 inches squared. You don't have to worry about the inches squared here. That's just square inches. That's the unit of measurement. It does not even really matter which of these you call the base and which you call the height, although this one is generally considered the height and this one is generally considered the base. So we need to multiply these two things together, and we need to think of them as if they were in parentheses. So to find the area, we'd multiply the base and the height, and we know what the area is equal to. So what we have is 2x plus 1 times x plus 1 is equal to 66. Now, we need a 0. We cannot take this and set it equal to 66 and this equal to 66. It's very, very tempting, but that only works if this number is a 0. It doesn't work if it's anything else. So what we're going to end up having to do is we need to multiply this whole thing out. We're going to have to move this over to the other side, and then we're going to have to factor again. So let's just distribute. 2x times x will be 2x squared. 2x times 1 is positive 2x. 1 times x plus x, and then plus 1 is equal to 66. So I'm going to be able to combine these two, and I want to subtract 66 from both sides so I can have a 0. That gives me 2x squared plus 3x minus 65 is equal to 0. Okay, so I need to solve this. I have 3 terms, no GCF, not perfect squares. So I'm going to be looking for two numbers that multiply to whatever 2 times negative 65 is. And that will be negative 130. And I want to add to a 3. Okay, so let's start listing things that multiply to 130 and see if we can find out where we can get a 3. So that would be 1 and 130, 2 and 65, 3 doesn't work, 4 doesn't work, 5 and 26, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 and 13, and that's it. Okay, I'm supposed to multiply to a negative, so one side is needing to be negative. I'm supposed to add to a positive 3, so that means my smaller numbers need to be negative. I can get a 3 out of this combination here. So I rewrite as 2x squared minus 10x plus 13x minus 65 is equal to 0. Now group here and here. From my first group, I can factor out a 2 and an x, leaving x minus 5, plus here I can factor out a 13, and that gives me x minus 5 equals 0. Therefore, I have x minus 5 times 2x plus 13 is equal to 0. Now set each of these equal to 0. X minus 5 equals 0, or 2x plus 13 equals 0. Here I'm going to add 5 to both sides. Here I'm going to subtract 13. I get x equals 5 or 2x equals negative 13. Divide both sides by a 2. And I get negative 13 over 2, which is equal to negative 6 1/2. I changed it to a mixed number here so that we can get an idea of what's going on here. We are asked to find both the base and the height. We are not asked to find x, so we need to figure out what these values completely are. If I plug in a 5, I get that this value is 5 plus 1, so that height would be 6. Okay. If I plug in a 5 here, 2 times 5 is 10, plus 1, I would find that my base is 11. Okay, that makes sense. If I take a negative 6 1/2 and I plug it in right here, I'm going to have negative 5 1/2. This answer, even though it is a perfectly good answer to this equation that we started off with, it is not an answer to this question. So we toss it out. This is what's going to happen a lot, not every time, but a whole lot when we have a quadratic that pops up in a real world problem. Okay, so let's try this one. It's extremely similar. We are told that the volume of this box, length times width times height, and it does not matter which you call which, it has to equal 140. Okay, so I'm going to multiply these three things together to get 4 times x, so 4x times x plus 2 is equal to 140. Okay, now I'm going to show you a trick here. I mean, we can multiply this whole thing out, move the 140 over, and it's workable, okay? But if you see a way of getting your numbers smaller, you might want to check that. So here's a trick. Everything here is multiplied together. Well, I mean, I would have to calculate this and then multiply. So that means I'm allowed to divide this 4 away. I'm going to divide both sides by a 4. So on the left-hand side, I get x times x plus 2. And 140 divided by 4 gives you 35. This was not a necessary step, but it does make your numbers smaller and much easier to work with. Okay, now just like on the problem above, it looks factored and you're tempted to set each equal to 35, but that doesn't work. I'm going to have to distribute here. And that gives me x squared plus 2x is equal to 35. And I need a 0, so I'm going to subtract 35 from both sides. I need to factor x squared plus 2x minus 35 equal, and then that's equal to 0. Okay, so no GCF. I have 3 terms, and that's not a perfect square. This is a 1, so I get to use the easier form. I'm looking for 2 numbers that multiply to a negative 35 and add to a positive 2. Things that multiply to 35 are 1 and 35. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 and 7, and that's pretty much it. Okay, so one of these needs to be negative, and it will be the negative 5. That's going to give me the positive 2. So this factors as x minus 5 times x plus 7 equal to 0. Now set each of these equal to 0 and solve. X plus 7 equals 0. Now we're going to subtract 5 from both sides, and here we're going to we're going to add 5 to both sides. Here we're going to subtract 7. That gives me x equals 5 or x equals negative 7. Now, one thing I do want to point out is that sometimes a negative answer is going to make sense. So you cannot just assume that it needs to be thrown away completely. Okay, let's take this 5. I'm asked to find the height and the width. I'm supposed to find basically all sides. I know that that's 4. This would be 5, and 5 makes sense. This would be 7, and that would make sense as well. However, if I put a negative 7 right here, or a negative 7 right here, I'm going to have lengths that are negative numbers. So even though this is a perfectly good answer to this equation, it is not an answer to this problem. So we toss this out. okay? It does not matter which of these we call which. So the two sides I'm looking for are 5 feet from here, and then 5 plus 2, which is 7 feet on the other side. So those would be your answers.